Welcome to Days at Dogwood Canyon, a nature podcast brought to you by Dogwood Canyon Audubon Center in Cedar Hill, Texas. This is a podcast that will take you into our 200-acre wildlife preserve in the heart of the DFW Metroplex. Take a quick weekly break with us and get outside with the fresh air, the trees, and of course, the birds. My name is Kiersten and I'm Center Coordinator Community Programs here at Dogwood Canyon Audubon Center. Welcome, listeners, to our Days at Dogwood Canyon podcast. This is a podcast about nature, birds, plants, and us. We will talk about how we all rely on each other to live our best lives. In this episode, we're going to talk about two things that very few of you have heard of, or so I predict. I know I hadn't heard about these things until I read the article in the spring 2024 edition of Audubon magazine. The article is titled, "Must Add Water." It was written by Andy McGlashen with amazing photographs by Mike Fernandez, and it talks about Saline Lakes and the Wilson's Phalaropes. To begin, yes, Saline Lakes do exist. They are not fantasy landscapes in a science fiction novel or a role-playing game. The definition of a saline lake, explained by the Encyclopedia of Inland Waters, is as follows. Inland saline lakes refer to bodies of water located in semi-arid or arid regions with high salinity levels due to evaporation. These lakes are typically found in closed drainage basins and are influenced by climate variations with important ecological, economic, and cultural significance. End quote. National Audubon has identified 9 saline lakes in the United States that are of significant importance, and they include, but are not limited to, Great Salt Lake, Salton Sea, Abert Lake, Mono Lake, and Owens Lake. These lakes support a very specific habitat that relies on salinity levels that must be within a narrow range to function in a healthy manner. This habitat supports small invertebrates that in turn support migrating and overwintering birds. That brings us to the second topic of this episode that you may not have heard of, the Wilson's Phalarope. The Wilson's Phalarope is a bird. You may have guessed that since this is an Audubon podcast. But specifically, the Wilson's Phalarope is a shorebird. They are a medium-sized, long-legged sandpiper with gray-brown underparts and thick red-brown streaks on the back and shoulders. Their underparts are white with red-brown markings on the upper sides. They have a gray crown and a white face. A black eye line begins at the base of the beak and continues through the eye and down the neck. Their bill is black, long, and needle thin. Wings are gray with darker flight feathers. The tail and rump are white. The females will be similar in color, but they'll be kind of brighter. They eat small invertebrates, including mosquito larvae, brine shrimp, and crane flies. Okay, now that we know what these two entities are, how do they fit together? Join me on a journey to Mono Lake in California to find out. Our story begins in the tiny town of Lee Vining, California, at the eastern base of the Sierra Nevada. We join Ryan Carl, the science director for the nonprofit research group Oikonos Ecosystem Knowledge. Ryan has come to Lake Mono to catch phalaropes. He and other researchers from various universities have been trying to catch these unusual birds for a week with no success. They have tried netting them by hand, catching their feet in loops of fishing line with a homemade device that looked promising, but ended up sinking to the bottom of the lake. Don't worry though, Ryan swam to the bottom and retrieved it so as not to unintentionally drown any wildlife. Why are they so keen to catch some phalaropes, specifically Wilson's Phalaropes? Well, we know very little about this bird. We do know what they look like, as just described. We do know what they like to eat and where they can be occasionally seen throughout the year, but we don't know how many there are or where they travel during migration. Ryan and crew are trying to catch the Wilson's phalaropes to learn more about this species. They will weigh and measure them, hook them up with little bird bling in the form of a bird band on their leg, and some of them will receive a tracker as well. This will help us learn about their movements throughout the year so we can better understand what resources they need to have a healthy future. The Wilson's phalarope is inextricably linked to the Saline Lakes in North and South America. This bird depends almost entirely on the resources that Saline Lakes offer, resources that can be found in no other habitat on Earth. In past years, Utah's Great Salt Lake has hosted more than 500,000 Wilson's phalaropes preparing for southern migration. While they are over-summering at our saline lakes, they're preparing for the long journey to Argentina on the southern tip of South America. After breeding, rearing, and fledging their chicks, it's time to begin migration. In June, the Wilson's phalarope will molt out of their breeding plumage and grow in their winter plumage, and this must get them down south. To molt and regrow your entire set of feathers in just a few weeks takes a massive amount of energy. They get this energy from eating the invertebrates offered at saline lakes like Mono Lake and Great Salt Lake. This all sounds pretty straightforward, right? Yeah. So what's the problem? 500,000 birds? That sounds like a lot. And they have at least 2 saline lakes that they have been spotted at, so things are going well for Wilson's phalaropes, right? Well, there's a bit more that we need to discuss. The saline lakes that these birds rely on for survival are disappearing. A 2023 report focused on the Great Salt Lake in Utah indicates that this lake, North America's largest saline lake, is on track to disappear in 5 years. This is a problem for all of our saline lakes. The main reason is overuse of water for human consumption and mismanagement of these bodies of water during drought times. If managed properly, these lakes can recover in high-density rain years, but nearby cities are ignoring the warning signs. When these lakes lose too much water, the salinity rises as salt does not evaporate, and this imbalance kills the brine flies, brine shrimp, and other invertebrates that are adapted to live in these lakes. Without them, Wilson's phalaropes will also perish. But wait, what about that 500,000 bird population I just talked about? Recent counts of Wilson's phalaropes have declined by roughly half since the 1980s. In 2019, their numbers were estimated at 350,000, with a steep decline in 2023 at a count of only 74,000. Losing these saline lakes is a huge problem for the wildlife that depends on them, but it is also a danger to humans that live nearby. As these lakes evaporate or the water is pumped out, lake bed is exposed. On windy days, dust laden with heavy metals and particulate pollution travels to nearby residents, increasing the risk of major health problems like cancer. The brine shrimp fisheries that supply aquaculture companies with these small crustaceans will cease to exist, hampering a $60 million industry and putting hundreds of people out of jobs. It's not just the Wilson's phalaropes that need the saline lakes to survive. These amazing birds aren't just relying on the saline lakes of North America. They have to have wintering grounds as well. That's where Laguna Mar Chiquita comes in. This lake is where you'll find Wilson's phalaropes in the winter. The saline lakes of this region are also in danger of drying up. So in 2022, Argentina created the Andalusia National Park, and that includes Laguna Mar Chiquita. The wintering grounds of the Wilson's phalarope is now protected by the government of Argentina. Researchers from the U.S. and Argentina are now gathering to work together to bridge the gap between two countries to help the Wilson's phalarope survive. They have to have lakes at each end of their migration if they have any hope for a future. Audubon and the Nature Conservancy is helping by managing a trust for the state of Utah aimed at protecting and properly managing the Great Salt Lake. Ryan Carl and the other researchers are continuing the fight by analyzing radio tracking data from 10 Wilson's Phalaropes that were fitted with devices while in California. This data has already revealed new insights into Wilson's Phalarope migration. By the way, it turns out that shining Phalaropes at night with lights was the best way to find them on their migratory stopovers. We can help the fight by encouraging our cities and states to look closely at where we get our water for human use, and if we must tap into a saline source, carefully manage that use. We can shrink the high water use of our lawns down by planting native plants that do not need copious amounts of water to survive, and tell others about what you learned by listening to this podcast. We can't fight for the birds we know nothing about. If we all take some action, maybe the Wilson's Phalarope will have a chance to keep breeding, molting, and migrating. I beg pardon if I mispronounced anything. I did try my best.